Hello everyone, we are with a new video series on my pairing sessions. I should create a playlist for pairing sessions. Uh, Today we have Chris Bimson as a colleague from Codurance, and now uh, which company are you in at the moment?
I am now the head of software development for HugHub, a company that sells a SaaS insurance platform. But I'm not here to shill, so I won't say too much more about that.
um, and today what we are going to be doing is we are going to be doing the Gilded Rose kata, which is all about refactoring, and we are going to do it on F Sharp. Chris.
Yes, so I was the one who chose F Sharp as the language to work in because obviously being a manager these days, I don't actually do much programming, and I thought, what a better way to show off than by pick a language I haven't used for 3 years and record it and put it on the internet. But when I did use F Sharp, I had a lot of fun. It kind of became my main hobby programming language for a little bit. And yeah, and while I've seen the Gilded Rose kata before and done it in other languages, I haven't looked at it for a couple of years now, probably. So yeah, should be fun.
Awesome. And I can see that I didn't check before. I can see that my screens do appear on the recording, which is it's great. um,
Oh, I'm the one sharing, aren't I? Okay, so I guess I'm driving.
yes. Oh, sorry. I did forget to mention. Guess
All right,
with
well, this is going to go
license.
slowly then while I have to look up every bit of syntax because I
Yeah,
can never
yeah.
remember.
It's
Okay.
fun. Well, if we run the test so people can see what do we
It,
have on test. Um,
well, what I'll do is I'll start by showing off this test. So this is it's called an approval test. What this does is there's an embedded, well, there isn't actually an embedded resource in this assembly. It's not really important. There's essentially the output of the program in a text file. And what this test does is load that output from the text file, connects a fake standard in and standard out, and then runs the program, captures the output, and compares it to the persisted output to make sure that everything is still good. So if I just run that now, I'll bring that up a little bit just in case it gets cut off by the recording.
People just so you know, this version of the Gilded Rose kata, is the one that Emily Bache has on
I'm terrible. I
her
can never remember how to pronounce her name.
yeah on her repository on GitHub. So she has a collection of these same kata, multiple languages, so you can go and do whichever you want.
So that ran incredibly quickly. So I'll just do it again to prove I wasn't faking it. So you can see it's past there. What I'll do is I'll quickly run the actual program itself, so you can kind of see the output in a window as well.
Yeah, good idea.
And you'll see it matches what's in that text file. Oh, well, okay, sorry, in the console there. So you can see it always spits out the same content because the input is hard coded.
Mm-hmm.
And you can take my word for it that it matches what's in here. Well, that and the test that passed as well, I guess.
Yeah.
So what other tests we got here? We've got a unit test.
A unit test that fails. So at some point we are supposed to kind of fix that.
What is it supposed to do? Because it's just called my test, which it's not a huge clue about what it's supposed to be doing.
No, I think this is an example of how you can do a test. I think that one of the main things on this one is that it uses the unquote library from Swensen, which is this one over here
Good.
at the bottom.
A new thing to learn. Brilliant. How does that work? So what's supposed to go in that little string on the left? I assume that's wrong.
Yeah, so you're supposed to. So I think
right. So if I change this to this, it should pass.
Yeah.
Oh, what do you know? So I'm not the world's best F# programmer. What's this syntax for?
Okay, so this operator, it was added by the unquote library, so you can kind of define your own.
Oh, right, I see.
Your own syntax. So this one is done in such a way so there is a capture. So the idea is that if when it fails, you get more of the stack that you will get otherwise.
Right, I see.
with a normal testing library like SUnit.
So in here can just be a normal F# expression tree.
Yeah.
Okay, cool. Okay, I think I got it. Well, we'll see what happens when we try.
Apart from tests, they have a few other things. You have they have a few inline stuff to do comparisons, and then they have a race width, so you can check for exceptions and whatnot.
Okay.
And actually, I forgot. Let me double check now. The whole idea with the Gilded Rose kata is that you want to add something new, but
yeah, are the rules actually in this in the repo?
there, the version that have copy you maybe is missing the. Oops, maybe it's missing the it should be missing the README file. Let me see if I can get it. No, here. I look for Gilded Rose kata. Gilded Rose. I should have it here.
Because if I recall rightly, there's a new type of item that needs to be added that has a whole new set of rules to the existing ones. That's
exactly.
Right, isn't it?
Let me see what it is.
Is it worth? I'll talk through and explain the conceit of this as I remember it.
Yeah. It's conjure. So what we have to add is it's conjure items that they grade at twice the get quality at twice the rate as normal items.
Okay. You've probably got the README file to hand, so you can correct me if I say anything wrong here. But as I remember it, this is apparently based off some World of Warcraft lore. Who never played it, don't know. But essentially, you're kind of modeling a store that has a number of items in it, as you can see from this sort of list of things here. And as time passes, the items in the store, essentially, they have a sell-by date. And as time passes, and that sell-by date decreases, rules affect how that item is affected. So, for example, I think the default kind of item essentially gets cheaper over time as it gets worse quality. There are some types of items that get better in time as they kind of like age. And I believe there's a type of item that's essentially immutable that never changes. That's always what the Jorge is highlighting there that never changes. And the conceit of the kata is we have to add this new type of item, I guess, here at the bottom.
Yeah.
This conjured item, and that has additional rules that I don't know off the top of my head, but I'm sure we'll find out shortly.
So,
the reason why this is hard is because here's the code that calculates the rules. So yeah, obviously we'll bash this out in 5 minutes and then move on to something else.
Yeah. Okay. So the new rule was the conjure items, which basically what they do is reduce quality at twice the speed as a normal item. So there are what we have over here. There are a few of them that they keep quality all the time, like sulfuras. There are ones that increase value until they reach the sell by date and then decrease to 0, if I remember correctly.
Oh yes, they're kind of like they represent tickets, don't they? So something passed to an event. So once the event has happened, they're worthless.
Exactly. And a couple of other ones that they just reduce as time passes by. They reduce their value, their quality. So some of them stay, some of them reduce, some of them improve, and then the others that start improving and then goes to 0. And then you have this conjugate that should be reduced by the speed.
Okay, so how do you want to go about tackling this then? I mean, if I had to do something like this for real and I saw code that looked like that, even though I had a simple test case that kind of The advantage is I have a simple test case that essentially captures the behavior of it as it exists.
Mm-hmm.
So I know I can't break it too badly. But even though I wouldn't try and add the behavior into this because this is a mess, I would try and refactor this to make adding the new behavior simple. I don't know. I don't know which way round you do it, Jorge. Whether you try and hack the behavior in, then refactor it.
I would. There is. How's his name? Kenbeck. Kenbeck always says, make the change easy and don't make the easy change. Which is probably the whole idea of the Gilded Rose kata, yeah? Is get the refactoring done, so adding the new one becomes pretty easy to do. And on top of that, I can see quite a lot of things going on over here, like this is assigning.
Yes, that's mutability in F#, isn't it? Which is not something you would normally do.
Yeah, and you can do it, but mutability in any language is just makes things more complicated than it should be.
Yeah, I mean, and the reason I got into F# is I wanted to get better at functional programming, and generally one of the kind of core rules of functional programming is you don't mutate values.
Mm-hmm. Yeah.
So that again, that's something I'd quite like to fix if we could.
Okay.
We also have a type, don't we? This is like a class. I would be inclined to get rid of that if I could, because I try and stick to just modules and functions when I'm in F#, but it's kind of like it's a me thing. It's not necessarily a quirk.
What is the?
It's right. We can leave it.
No, okay. We could remove the type as well if no, the type can even be useful. Because it's more or less like it's a structure, yeah. The specific type that we have over here, so it's not problematic. At least not right now. Maybe later on we want to change that.
Yeah, I mean, one of the things that sort of leaps out at me is we have an item to capture the things that are in the store.
Mm-hmm.
And different types of items have different behavior, but we don't model those different types in the system. We just have one. That feels, given how strongly typed F# is, that feels like a little bit of a weakness.
Yeah, I do agree. So what we do first? Do we try to extract first functions out of the multiple stuff that happens over here, or do we try to start extracting? Get the different types that we are gonna have that we could have rather, yeah. So the fact that we have H3, so yeah, H3 for example, or
Yeah, I don't know, because I feel like if we extract all these, because it's not the actual doing parts themselves that the problem is, it's the conditionals, and the conditionals are nested in weird ways. So I'm not sure if we just started extracting those, we'd necessarily end up with anything that much better. I mean, well, here's just an experiment. I mean, if I was going to model this in F#, I would probably want to do something like, we'll come back with a good name later.
Yeah, don't worry about it.
And I think you do it like this, and you say you would have like normal item. Am I doing this right for a discriminated union?
Yep.
And then we have items that get better as they get older, don't we? So appreciating item?
Yeah, let's gonna go with that name for now.
And then we have
the ones that have a constant quality.
Oh yeah, they have a name in the rules, don't they? They're called legendary items or something.
Yes. Yeah.
Whoops, sorry.
Actually, that reminds me. Do they give names? No, it doesn't give any other special name.
No, they kind of go with very specific examples, don't they? And then the last one is this ticket.
Yeah.
If I believe the rules of that, it rapidly gets more valuable and then crashes to zero, right?
Yeah, so that will be the appreciated item. appreciating item, then
Well, no, because appreciating items, don't they just keep rising in value?
oh,
They never go back down.
oh yeah, okay. So yeah, so there's a difference. Yeah, you are correct. You are correct. So there is one additional type. Whereas, what name we can give it?
I don't know. What do you call something that gets really valuable and then is suddenly not valuable? Crash
Twitter.
item?
Twitter.
Twitter. Topical. If we're gonna get topical, we could just call it crypto item, couldn't we? That gets really expensive and then it's worthless.
I don't know.
Should we just? Oh, how about since they represent tickets? How about we just call them scalpable item?
Yeah. Okay.
Because that's basically what happens with tickets, isn't it?
Yeah.
Apparently, Ryder doesn't think that's a word. Whatever. Pretty sure it is. Oh, and then we're going to have a new one, aren't we? Which is
the conjure item.
Conjure item, is that right? No, that's not right. Conjure.
Yeah.
So the kind of the line of thought I'm thinking is then when we come to update the quality of the item, the first statement of that function is we do a match on the type, and then we can split the behavior by the type of item.
Okay, so in fact, then what we can do. Oh, this is a for loop.
So I want to do a small change. So I think this will still work if we just change the input rather than from items to specific items. Correct?
I think.
So if I do, I can't remember the syntax for this. Is it? Did I call it a standard item? No, I called it a normal item. That's a terrible name, right? Because it kind of is it.
And you have to.
Is it like a constructor type syntax?
Yeah.
Is it like that? Okay, so it won't like that. Oh,
no, because it has to be better items. Then the whole thing has to be better items everywhere.
Okay, well I can probably do that without too much problem.
And then okay, so
I probably could have used the refactoring tools to do this. Me being out of date.
Don't worry about.
Oh no, this isn't going to work. Actually, let's go.
No. We can do. There is something that we can do around this.
Okay.
So just finish doing all of them.
So Agebury is
appreciating.
I don't even need those curly braces. Okay, cool. No, not curly braces, the regular braces. So this one is regular?
I think that's normal, yeah.
This one's the legendary one, isn't it? Yeah. I remember this one
the
because I had no idea. I still don't know what that is. These ones are the scalpel ones, aren't they? Because they're backstage passes. Which must make the last one 100. Okay, so right, so there are two. How does this work? We need to downcast the items here, don't we, or something?
Yeah. So probably what we can do is extract at this point on time over here. We can extract the actual item.
Oh, right, I see. So something like
no, because you just do that. There's still better item over here, yeah. So you hover over item, it should tell you there is a better item. No, what you need to do is what you need to do is extract the inside of items.
Oh, I need to deconstruct it.
Yes.
So what's the syntax for that? Is it something like?
I think it's on the other. Oh, let me remember this. I haven't touched.
I remember how to do it. I remember how to do it for a new tuples, but not for unions.
If I remember correctly, it was no, it was a batch statement where you have to add for the. Yeah, I think we are gonna have to use
Oh,
a
actually, I
match
think I know what you mean.
statement.
We have to do this, don't we?
Yeah.
I didn't. It's a bit bigger change than I wanted to do actually, but okay. So then we have to put a case in for each of those types. So
Yeah, what you want to do is let me see. With thing, so you still have to put the parents over there and then do the extraction of the value. I think.
oh, so is it no?
No, with yeah, like that. Remove the knee at the end. Remove that with knee. Yeah, remove that. Yeah, and then you should be able to use. You do knee dot over here something on the right hand side of the. Yeah.
Oh, yeah.
So that's the way to extract it. Yeah. What I so what you can
So
do.
actually, if I did this, then
Yeah.
and does that work?
Yeah, and then you should be able to wherever it's using items I, you just use item.
Yeah, I just have to do this. I'll tell you what. Let's do it the same for all of them. So I have to do this
For all
for
of
each.
them.
Okay, that's kind of. Oh well. Guess I'm kind of committed now, aren't I? This is a much bigger change than much bigger change than I wanted to make. So I don't hope it doesn't get bad.
Nah,
So
you'll be
that.
fine.
Oh no, I've missed one. Sorry. So I need scalpable item. And now I should be able to replace items.I with
With item, sorry, with item.
item. Let me just check that the compiler agrees with that, and I'll do it with find and replace. Cool. Okay, so then I should just be able to get all of that. And I want items.I, and I would just want to replace that with item. Forgive me for only doing it one at a time. I just like to double check as I go. Okay.
Okay, so now it still gives you.
Because the item needs to be mutable then because we're using that operator.
So you can for now, yes. No, I think it's. Oh, I thought it was just mute. Oh, that is Rust maybe. Yeah. Okay. Awesome. So you run the.
if I run the test, that should still work. Oh, we need to do it down here as well.
Yeah.
Oh, that's annoying. So can I? It might be worth extracting this just into a function of its own. Then
no, I wouldn't do it at this point in time.
Okay.
I will copy paste. It's because there's gonna be a change. The one above is gonna change completely later on. It's not gonna just extract the item. Yeah.
Okay, fair enough. Fix my indenting. And then I can just replace that with item, I believe. Correct me if I'm being an idiot.
No, it's everything fine so far.
Okay, and I think if I save that, let's go. Oh, right. We'll build it then. Let's have a quick look at that. So our approval test should still work. Index was out of range. Oh, now I've done it.
Huh.
Oh, because I copied and pasted it.
Oh.
Where's that built? Yeah, that's why you don't copy and paste things, kids.
Where's that one?
Oh, it's in the tests.
Oh, this is self. Okay.
So if I just do
and just
and this
normal
standard
item. Yeah. Normal.
item. You already know that's a bad name because I keep getting it wrong and I only came up with it about.
Yeah, so we are gonna have to extract the type over here. If you do a match, you can still do a match outside and then do the test. And the
Okay. So if we do the same again, then so
actually do a match over here. So match item 0.
I think I know what you're going to do, but go ahead.
Yeah.
Item 0 with, and then we want a normal item, and
you can just pass give it a name and then just call this one on that. Yeah.
Right, and then just ignore everything else.
Yeah, you have to add the else statement. Is else statement the full statement? I don't remember right now.
You do. Don't you do this?
Yes, that's it. Underscore.
Apparently not, because it wants something else. Oh, then you have to do something, don't you?
Yeah.
And then you can just do straight to ignore.
Yeah. No.
Must return values. Well, this doesn't actually. What does test return? A string.
Yeah. No, it's unit. Oh, just
Unit.
put unit. Open and close parents. To do the trick.
Okay.
I think there's a better way of doing this, but we can deal with that in a second.
I mean, this isn't a real test anyway at the moment, so I'm okay kind of just hacking this one to stop it. Failure? Well, that's... Really?
Where? Oh, it's in the approval test.
Ooh. How did we break that?
Interesting. So the only possible reason that we have broken that is that when we
I know how we've broken it.
Yes.
Because it was originally actually pushing stuff back into the array, wasn't it?
Yeah.
We're manipulating this item, but we're never putting it back in the array.
Absolutely.
That's really rubbish, but can we do that right at the end? Can I do...
No, because you need to know the type, yeah?
Man, that's annoying.
Ooh.
Oh, no, I don't, because this is still an array of better items, isn't it?
Yeah, it's just... it's an array of better items, but this one is just a normal
I've deconstructed it, yeah.
Yeah. So, okay.
So what I actually need to do is it's not this mutation I want. It's
yeah, but you still need to cast it to the proper type.
Yeah, but I can sort of do that. Can I?
No, because then you have to think which one it is. Is it a normal item? Is it a presetting item? Well, in fact, we can... Yeah, if you do this, you could be changing the type of the item, yeah?
Yeah, this is actually getting a bit sketch, isn't it?
Yeah, but we can still do something with this. Extract the whole if statement into its own function, into a new function. The whole, everything, the whole.
Oh, right. Yeah. Do I have a refactoring for that? No. Cool. Okay. Fair enough. I know it's
up to there. Yeah. Okay,
so
this one is running a bit longer than I wanted, but let's gonna try to create a new added order. Order is important, so it has to be declared before.
oh yeah.
Added
Another
as
member.
as a member
function.
for now. Update item or something like that.
Yeah. Oh, sorry, missed the equals off.
Yeah. Paste. Awesome. No. Okay. So let's gonna go to the top to definition. This one should get an item. Item.
Right. Sorry, I think I see what you're doing.
Yeah. You need to space and give it a name. Item, which.
Sorry, if I
Why is complaining?
have I screwed up the indenting?
Oh no, it's because of the. Go to the bottom. Go to the bottom. Keep going. We haven't copied the final parents. Yeah, which has to be further there. I think it is there.
Or is it aligned with member? No.
No,
Aligned with the
that's.
first name.
I know this one is not doing anything. No, okay, no. I don't.
Looks like we're missing an else. Oh, it's actually the formatting is all over the place, isn't it?
Yeah.
Let's try to let me go back a couple of steps and try and redo that in a way that's not terrible.
Oh, we can do something slightly different. So undo everything. Move. Extract the for statement and delete, and just rename this one. So kind of the opposite of what we're doing.
I get it. So if that's not a bad idea. So if I do, and then do.
Now the.
You still there, boy? Can't hear you.
Yeah. Can you hear me?
Yeah. All good.
Okay.
Just get rid of that a sec. What was I doing? This. Oh yeah. So I was just simply moving this to there, and you can't have a let as the last thing, but let's worry about that later.
Yeah. So pass item over there. That's fine.
Missing a colon. Sorry. Fix that. No, it's the wrong way around, isn't it?
No, it's of type item. Yeah. Sorry, it's a colon item. The order is this is not C#.
Yeah. I mean, it didn't. I don't think it actually needed the type in.
Yeah. So let's gonna. Okay. Can you go down a second? Okay. So we have to declare immutable. I think we can put it over here, mutable.
Sure, it doesn't go at the end.
Oh, I don't remember enough. No, the other possible position will be this one. I'm just at the moment I'm getting confused with Rust. Okay, so the problem. Can you go down a second over here? We are gonna finish in quickly. Okay, so the problem is that this is that's fine.
Can we just return a new item from this function?
So you cannot the
No,
thing
'cause
that I was thinking is that put a return over here, but that's not gonna work because you modify there is this if statement, then you have an if statement over here and another one over here. Yeah.
Yeah.
So you have kind of three if statements, and it's possible that the same item falls through all three of them.
All of them.
That's an actual possibility, at least taking into account how the code it is.
Okay, how about, can we be this lazy and just do...
Okay, yeah, return item at the end, along with the ifs, yeah. This one is part of the for statement. So that one should be the last thing of the. So remove this from here, the parents.
Remove this one?
Yeah. And go to the loop at the top. Add it here.
Right, yeah, got you.
Okay. So the last thing that we want to do is that we are gonna call update item on each one of them, and instead of being a let mutable, what we have is an item assignation. Or rather items y assignation, yeah?
Oh, right. So
you can even remove the let statement as well. Items, yeah, assign.
Good point, because it's a member variable, isn't it? Oh, no, assignment is that, isn't it?
Yeah. And then just pass update item. Update item, passing the I. And
do I have to do this?
No, it's because the yeah, okay, yeah.
Yeah, I made a member thingy, didn't I?
Yeah, it's still not gonna be perfect. There's one thing that we have to fix, but we come in a second. Yeah, and then just call it normal item this, set item this, legendary item this.
Sorry, I'm not following.
You have to put it back into the
into its containing type. Yeah. So
the other way around. Remove the parents.
Sorry, I get this confused with typecasting.
Yeah.
It doesn't like that.
Oh, it's because you have completely different types at the moment, yeah?
Yeah, so okay. As soon as because I need to deal with all of them, so
yeah. That's just the how's it called?
Oh, it still doesn't like that. Why not? Successive arguments should be separate. Oh, okay, fair enough.
No, maybe.
And then, is it like that? To make it evaluate it first? Yeah, okay. Still got a bit of C# on the brain, I think. And much fun as this all is.
I think there's a better way of doing that, but don't remember right now. That's fine. Awesome.
Right, let's try it. Let's see if that actually builds then. This is why mutability is a bad thing, by the way. just for future reference.
Run the test. Awesome.
Hooray, right.
Commit.
Let us commit that then before that gets any worse. Oh, whoops.
I should have, we should have refreshed our F-sharp before trying it.
Yeah, probably. It's a good illustration of why mutability is bad, I think, which is an important thing, I guess, for functional languages. Introduce strongly typed things. And I'll push that so you can have it.
Awesome. With that, this Pomodoro has actually gone far longer than originally intended. We
Yeah.
are gonna have a quick break, and then we'll continue. People, enjoy.
Okay.